Yuk.
Oke, mulai ya. Good afternoon, guys. How are you
Good
today?
Good afternoon. Good afternoon. I'm
Good
fine.
afternoon. I'm fine, thank you.
And you?
Okay. I'm okay, and I hope you all be okay. Because today we will discuss about kinematics and dynamics. As Mr. Wayan said, make a like and relax discussion. So guys, chill out. This is a like discussion. So let's get started. But first of all, for group 1, you may introduce yourself. Kelompok 1 boleh kenalan dulu.
Okay. Hi guys, can you hear me?
Yes, I hear.
Yes, Rini.
Okay, my name is Antika. With ID number 2113022063. Thank you.
Okay, thank you, Rini. From the other group 1, you can introduce yourself.
Hi guys, my name is Dhiya Puspita. My ID number 2113022023. Okay, thank you guys.
Okay, thank you, Diana. One more.
Hello, my name is Komang Satyawati. ID number 12130222005.
Okay, thank you, Rini Komang. So let me introduce myself. My name is Tangga. I'm not alone. So let me introduce my friends. Say hello to Della. Hello, Della.
Hello.
You look so pretty today. Okay. Then there is my friends too from group 2. Hello, Dhiya. Rihadatul ini. Hello, Dhiya.
Hello.
Okay. And last but not least, say hello to Amanda, Fajar, Arifia. Hello, Amanda.
Hello.
Okay. So the rules start from group 1. Please describe the conclusion from the material given by Mr. Wayan. For group 1, welcome. Silakan grup 1 boleh bacakan kesimpulan dari materi yang diberikan Pak.
Okay, thank you, Tamara. I will convey the condition of the kinematics material. Kinematics material is the study of motion, velocity, acceleration, and distance of an object moving on a path with constant velocity. This study looks at the reference point of an object as a point particle. In the kinematics, distance or scalar is the length of a path of object travels during its motion. The unit of the distance include the meter, centimeter, and kilogram. Meter, centimeter, and kilometer. In displacement or this vector variable is position of the object when it moves. The unit of displacement include meters, centimeters, and kilometers. Just it.
Okay. Thank you, Rini. So next, for group 2, may I ask question to group 1. So please write your question in column chat. Untuk kelompok 2 boleh tulis pertanyaannya di kolom komentar. I'm sorry, I mean column chat, okay? Okay. For group 1, you can answer the question now.
Okay, I will answer the question of Tamara. The question is, tell me about difference, distance, and displacement. Can acceleration be zero? Explain in your language. Okay, my answer is when acceleration is zero, or that is a equals dv divided by dt equals zero. Rate of change of velocity is zero. So that is acceleration zero when the velocity of the object is constant. How, Tamara? Is it clear now?
Okay, it's enough, Rini. Thank you so much.
Okay.
Okay, next from the other member group 1 can answer the other question.
Okay, thanks to the moderator. I will answer two questions from Tamara. Tell me about difference distance and displacement. Salah.
Okay, for group 1, you can answer the question now.
Okay, I will answer the question of Tamara. The question is like, can acceleration be zero? Explain in your language. Nah, my answer is when acceleration is zero. This is A equals dv divided by d equals 4. Rate of change of velocity is zero. That is acceleration zero when velocity of object is constant. How, Tara? Tara?
Oh, okay, it's enough, Rini. Thank you so much. And for the other member from group 1, you can answer the other question now.
Okay, thanks to the moderator. I will answer the question from Tamara. Tell me about different distance and displacement. My question is, distance is a scalar quantity while displacement is a vector quantity. Distance is the total path traveled by the object and displacement is the short path traveled by the object. Distance does not decrease with the increase. Displacement decrease. Distance is always equal to or greater than displacement. What about Tamara? Is it clear?
Okay, it's enough, Diana. Thank you. Okay, for the other group 1, you can answer the other question.
Okay, I will answer question for Amanda Fajar. Kelihatan nggak?
Okay, okay.
What is the shape of the strike motion? Strike motion consists of two types, namely uniform strike motion and uniformly chain strike motion. Uniformly strike motion is the motion of an object in a straight line at a constant speed. An object has a constant speed if the object travels the same distance for the same time interval. Will the strike motion change? Uniform is the motion of object in a straight line with a constant acceleration. The purpose of constant acceleration is acceleration that has a constant value of change is in speed and direction. Acceleration straight motion is the straight motion of an object, where the motion of an object whose speed v is acceleration in very second is in a straight line or straight motion whose acceleration is getting bigger. Uniformly saying straight motion is slowed down is the straight motion of an object, where the motion of an object whose speed v is slowed down every second in a straight line or straight motion whose acceleration is increasing small.
Okay, thank you, Komang. How about Fajar Amanda? Is enough answer from Komang?
Okay, that's no. Thank you.
Okay. For the other member from group 1, you can answer the other question. Buat kelompok 1, boleh jawab pertanyaan yang lain? Bisa mulai sekarang.
Okay. Guys, can you answer me? Diana? No, guys.
Okay, Diana, can you answer the question now?
Okay, thanks to the moderator, I will answer to question from Fadhilah. When do displacement and distance become equal in value? My question is, distance and displacement value will be the same if the direction of motion is in a straight line and in the same direction or not back and forth. What about Fadhilah? Is it clear?
Yes. No. Thank you.
Yes.
Okay, thank you, Diana. For the other member group 1, you can answer the other question. You can answer the other question now.
Okay, I will answer a question from Amanda Fajar. Is the strike motion of an object in everyday life general does not exist? Permission to answer. So there is a strike motion of an object in everyday life, such As for example, the motion of a straight line change uniformly, that is where the streets fall at a certain height, and from uniform strike motion, we can find the motion of the train on a straight track. How is Amanda Fajar? Clear?
Okay, no, thank you.
Okay, thank you, Nikomang. Next, for the other group member group one, you can answer the other question now.
Okay, thanks to the moderator, I will answer to question from Dhiya, Rihadatul, Aisy. How do you grab the velocity as a function of time of the velocity component in the vertical direction of the bullet motion and explain it? My question is, so the basic motion that occurs in every movement, in its development, there will be vertical upward motion or free distance motion with is a uniformly changing straight motion. In vertical upward motion, the object is slowed down by the acceleration due to gravity. What about Dhiya? Is it clear?
Okay, it's enough. Thank you.
Okay, thank you, Diana. Maybe one more question from group one. I'm sorry, from group two. Okay, one more question. Can you answer the question now? Masih ada satu pertanyaan lagi dari kelompok 2 yang belum terjawab. Untuk kelompok 1, silakan dijawab.
Okay. Can you guys? Hello.
Halo Rini ya.
Okay. Here I will answer the question of Fadhilah. The question is, can you give me an example of x equal x0 plus v0t plus 1 divided by at 80 square equation. So my answer is we know that the displacement take it the final portion minus the initial portion in the word, the difference between the position A. Not only that, the displacement we travel is the average speed times the time. The average speed is used because the speed change with time, where the average speed is the middle value of the initial speed and final speed. Then the average speed is equal to the initial speed plus final divided by 2. Okay, delta x equals Vt when V equals V0 V0 plus V divided by 2. So x negative x0 equals V0 positive V equals 2 times t. X min x0 equals V0 plus 0 plus 80 divided by 2 times t. So finally x equals x0 plus V0 t plus 1 divided 2 times a t squared. How is it clear now, Dhiya?
Okay, this is now. Thank you.
Fadhilah?
Yes, this is now. Thank you.
Okay, thank you, Rini. Is there more question? Masih ada lagi yang belum terjawab?
Iya, masih.
Oh, okay. Can you answer the question now?
Okay, I will answer to question from Dhiya, Rihadatul, Aisy. Uniform circular motion if the angular velocity and the radius of the processing object are doubled. What the acceleration of the centripetal and give the ratio. My question is, so if the centripetal force is increased by 2 times then the velocity will be directly proportional to the original velocity. What about Dhiya? Is it clear?
Okay, it's enough. Thank you.
Yes.
Okay, thank you for group 1. Now, from group 2, may I ask question? Sorry, I mean, for group 2, you can describe conclusion from the material given by Mr. Wayan.
I will answer question from Amanda Fajar. In your opinion, what is an example of an object in motion and an object at rest? What is the difference? Example of object moving, slingshot are offset by the spring force. The shoot of an arrow is influenced by the spring force. Bicycle is influenced by the friction force. Example of stationary object: pencil, pens, table, chair. The object cannot move without a force. The difference between a moving object and a stationary object: if the object subject to a force and experience displacement, the object is said to be in motion. Will an object at rest is an object that does not receive a force. How is Amanda?
Okay, thank you.
Okay, thank you to Nick Komang. Next, to group 2, please describe the conclusion from the material given by Mr. Wayan. The material is dynamics. Yeah, sorry ya Allah. Okay, from group 1, you can answer the question now.
Okay, this question of Fadhilah. So wait, I will read question first. The question is, can you draw a graph of S against T if the object reverse direction? Oh, the graph is the same, but is negative because it's reference direction. Since in the graph image, you can see the graph image with the line is getting higher and higher. How is it there?
Okay, this is now. Thank you.
Okay, thank you, Rini. So, next, group 2 will be described the conclusion from the material given by Mr. Wayan. For the member of group 2, you can start now.
Okay. Dynamics material explain about concept of force, Newton's laws of motion, Newton's first law, Newton's second law, Newton's third law, and then frictional force have two types of frictional force is kinetic and static. Thank you.
Okay, thank you, Della, for your conclusion. So, for group 1, you can may ask question to group 2. Please write your question in the column chat. Untuk kelompok 1 bisa tulis pertanyaannya di kolom chat.
Oke.
Biar kelihatan juga.
Okay.
Yeah. Okay. The question from group 1 will be answered by group 2. So the first, I will answer the question from Diana Puspita. How is the effect of mass on the acceleration of motion of an object that is given the same force? Explain using Newton's second law equation. Okay. How is the effect of mass on the acceleration? Newton's second law is okay. Newton's second law is force equal mass times acceleration. You can see the Della share screen. Yes. In the red type is force F for force equal M for mass and A for acceleration. The unit of force is Newton. We know that. And the unit of mass is kilogram. Unit of acceleration is meter per second square. With this equation, if an object is given the same magnitude of force, then an object with a smaller mass will produce a greater acceleration, while an object with a larger mass will produce a smaller acceleration. So we can talk mass and acceleration are inversely proportional, berbanding terbalik. How about Diana? Is that enough?
Yes, enough. Thank you, Tamara.
Okay, next I will answer the question from Komang Satyawati. The question is, why do objects with the greater mass have more inertia? The relationship between mass and inertia is proportional, berbanding lurus, which means that the greater the mass of an object, the greater too the inertia that the object has, vice versa. Begitupun sebaliknya. So, mass and inertia have a directly proportional relationship. Massa dan momen inersia mempunyai hubungan yang berbanding lurus. Is that enough, Komang?
Yes, enough.
Okay. Is that from me? For group 2, you can answer the other question. Thank you.
Next, I will answer question from Diana Puspita. Okay, I will share screen. Okay.
Okay, you can start now, Della.
I will answer question from Diana Puspita. The question is, explain the relationship between mass and inertia. The relationship between mass and inertia is the same. Mass is property of matter which is a form of resistance to force or inertia to maintain its position, whereas inertia is the inertia of a system to resist motion, such as mass. Okay. The tendency of an object to resist a change, okay, in its state of motion varies with its mass. The greater the mass, the greater the inertia. As a result, the greater the force that must be applied to be able to change the state of the object. This relationship is F equals M times A. Will be discussed further in Newton's second law. Okay. What Diana Puspita, it is clear?
Yes, enough. Thank you, Dila.
Oke, terima kasih. And I will answer question from Rini Antika. The question is, please give an example of kinetic and static friction. Okay. For example, you can see on my share screen, when we kick the, for example of kinetic, when we kick the ball will continue to slide and eventually stop. This is okay. For problems is example of kinetic, a wooden mass of 100 kilogram is put in a net. If the coefficient of kinetic friction is 0.2 and the acceleration due to gravity is 10 meters per second square, what is the static friction force? Okay, sorry, kinetic. Noun, mass is 100 kilogram. The coefficient of kinetic is 0.2 and gravity is 10 mass per sec s squared, and friction force. Okay, step 1, reviewing the force on the y-axis. Sigma Fy equals 0 and minus m times g equals 0 and equals m times g equals 100 times 10 equals 1000 Newton. Okay, step 2, substitute and into equation. Okay, this is the equation, and Fk equals 0.2 times 1000, and then Fk equals to 200 Newton. Okay. Second, for example of static friction can prevent object from sliding down an inclined plane. You can see in a picture on my share screen. Okay. Next problem example of static. An object weighing 30 Newton is on an inclined plane. Apparently, the right object will slide down if the acceleration due to gravity is 10 meters per second square. Determine the coefficient of friction between the object and the inclined plane. The answer, step 1, reviewing the force on the y-axis. Sigma Fy equals 0 and minus weight cos 30 degrees equals 0 and equals weight cos 30 degrees. Because the object is not moving, then acceleration equals 0. Then Newton's first law applies on the x-axis, which is as follows. Next, sigma Fx equals 0, weight in 30 degrees minus friction status equals 0. Weight in 30 degrees minus coefficient friction status times n equals 0. Okay. Coefficient friction status times n is equal weight sin 30 degrees, the coefficient friction status wake cos 30 degrees is equals wake sin 30 degrees. Coefficient friction status cos 30 degrees is equals sin 30 degrees. And then the coefficient friction status is equals sin 30 degrees divided by cos 30 degrees. The coefficient friction status is equals 1 divided by 2 divided by 1 divided by square root 3. And then the coefficient friction status is equals 1 per 3 square root 3. So the coefficient of friction between the object and the inclined plane is 1 per 3 square root 3. How with Rini Antika, it is clear?
Also, I think this very thank you, Fadhilah.
Okay.
Can you?
Okay. Is it enough, Rini?
Yes. Thank you, Fadhilah.
Okay.
Okay. Thank you, Della. And for the other member of group 2, you can answer the other question now.
Okay. Now I will answer a question from Diana Puspita. The question is, why does a rock reach the ground faster than a piece of paper when it is released from the top of a building on Earth? Itu share screen dan tolong.
Permission to Della. Can you share screen?
Okay, thank you. Previously, I allowed to refute Diana's question, which said that a rock reached the ground faster than a piece of paper. So, the truth is that both objects will fall together. Mereka jatuh berbarengan, bukan batu duluan. Maybe you are confused why it can be together. The rock should fall first. Okay, look at the following picture in the last share screen. Based on the picture above, it is clear that the stone fell first. Why? This is because the surface of the paper is much larger than the of stone and is generally thinner, allowing for air resistance. What if we make the paper surface smaller? If we clamp the paper or clamp up until there is no gap for air to the entered paper, like the picture above, the two objects will fall together. Because the air resistance on the paper will decrease and eventually equal the air resistance on the rock and the acceleration due to gravity on the rock and paper is the same, which is 9.8 meters divided by second square. We can also prove this experiment through the formula. Energy is conserved, so the mechanical energy of one is equal to mechanical energy of two. kinetic energy plus potential energy equals kinetic energy 2 plus potential energy 2. Because the two objects do not have initial velocity, then A key equals 0, and because when the object hits the floor, the object does not have a height, then AP 0. So we get the equation. EP equals EK2 or mgh equals half mv squared, and the velocity formula is as follows, which means that the mass of the object does not affect the speed of the object, but the height and acceleration due to gravity. Since the two objects have the same height or h and the acceleration due to gravity or g, the velocity of the two objects will be the same as well. So the conclusion first is two objects with different mass will fall at the same time, and two, all objects fall with the same acceleration due to gravity, 9.8 meters divided by second square, provided we ignore air pressure. That is all how it's enough. Diana?
Yes, enough. Thank you.
Okay, thank you, Amanda. For the other member from group 2, you can answer the other question now.
Wait, Tamara. One question, one more.
Oh yeah.
I will answer question from Rini Antika. Help Della to share screen. The question from Rini Antika is, if two objects have different size and opposite direction, what is an action-reaction force? In Newton's second law and first law, it is explained that if an object is given a force, then the object will move. The greater the force applied will determine how far the object moves, and the object will try to maintain its position. An object that is at rest will remain at rest, and an object that is moving in a straight line will move in a straight line. So, Newton's third law reads, the action and reaction force of two objects have the same magnitude in reverse direction and are in line. This means that if there is object A that exerts a force of F on object B, then object B will exert a force of F on object A. F and minus F has the same magnitude but different direction. This law is also known as the law of action-reaction, where F is called the action and minus F is the reaction. So, Newton's third law explains that if an object gets a force, that the object will send an opposite force with the same strength to the source of the force. If simplified, This third law has the following condition. The magnitude of the force is the same, the direction is opposite, and act on different objects. So, if two objects have different magnitudes, it is not included in the action-reaction force even though the direction are opposite. This is because his statement does not match the sound of Newton's third law. That's all. Sorry if there are mistakes. Thank you.
Okay, thank you, Amanda.
Okay, thank you, Amanda, for Dhiya Rihadatul Aisy. You can answer the question now.
Okay, I will answer the question from Komang Satyawati. The question is, can an object experience acceleration if there's just one force working on it? Yes, as long as the force applied is able to make the object move. So that acceleration occurs whether the object is initially at rest or in motion. According to Newton's law, F equals ma. When an object is given a force, it will experience an acceleration that is directly proportional to the force. That's enough for me. Is enough, Nikoma?
Yes, enough. Thank you, Dhiya.
Okay. And I will answer a question from Rini Antika. The question is, please explain an example in everyday life to Newton's law of motion. I'm here to explain 10 examples of Newton's to law in everyday life. In the first example, that is bus driving on the highway. A bus traveling on a highway will get an acceleration that is proportional to the force and inversely proportional to the mass of the bus. So the greater the mass of the object, the greater the force exerted. Next slide 2. In the second example, that is on the elevator working system. In the elevator work system, there is also a force for an elevator that is stationary of moving at a constant speed. The normal force N will be the same as the Earth's gravitational force V equals mg. Meanwhile, for an elevator that is moving, it is accelerating or decelerating, then the compressive force will be the same as the normal force but not the same as the Earth's gravitational force. Next. In the third example, that is in the game of marbles. In the marbles game, the smaller marbles, when played, will roll faster, while the larger marbles take relatively longer, acceleration is inversely proportional to their mass. Next. In the fourth example, that is, objects with small mass are given the same force, and object with a small mass is given the same force as an object with a large mass will experience a greater acceleration than an object with a large mass because the acceleration is directly proportional to the resultant force. Next. Next slide. In the fifth example, that is, move object to a higher position. When you move an object to a higher position using an inclined plane, it is also an example of the application of Newton's second law. Next. In the sixth example, that is, when pelling a cart. When you are pelling a cart full of load, of course, the force you give is greater than when you are pelling a cart without a load or empty. Next. In the seventh example, that is drawing well water with a pulley. When you are drawing water from a well using a pulley, in this activity, there will be a force due to pulling a rope that is connected to a bucket filled with water through a pulley. Next. In the eighth example, that is, rhinos passing each other. When the large rhinos pass each other, the smaller rhinos, so that the smaller rhinos will bounce. This proves that there is a concept of Newton's second law because the greater the mass of the object, the greater the force exerted. Next. In the ninth example, that is, truck car carrying cargo, a truck carrying a small amount of cargo can get a greater acceleration than a truck carrying a lot of cargo. Next. In the 10th example, that is, passing the meatball cart, people will pass the meatball cart with a certain force, and the cart will run with a certain acceleration as well. That's enough for me. It's enough, Rini Antika.
Now, thank you. Yeah.
Okay, thank you, Dhiya. You explained very clear. Okay, is there Is there more question? Apa masih ada pertanyaan yang belum terjawab? Okay. So, until here our discussion today, hopefully what we discussed earlier can be useful for us. More or less, okay, until here our discussion today, hopefully this discussion can be useful. Less and more, I'm sorry, and good afternoon, guys. Thank you.
Good afternoon. Thank you.
Good afternoon.
Good afternoon. Thank you.
Thank you.